Welcome back, everybody. It's been a little while since we did the last stream, but yes, things have been moving along in the background quite rapidly, and we're at a point where I can show you some stuff that's happened. So, quick recap: what are we doing? We're trying to make new pick and place machine software, but as part of pick and place machine operations and workflow, there's a few parts to it. Basically, you've got control of a machine, with like stepper motors and all this kind of thing, right? That's one area of it, and there's a lot to that. We're going to get to that. But the other part of it is just like organizing the work for the machine to do. And that is just like a massive topic all by itself. And we're trying to do it all, and currently there's only me doing it, and it's a lot of work. Anyway, so we've been working on the job workflow, and that is where you go from a design in your EDA software to actually getting components and putting them on a PCB, whether it's manually or by a machine. The steps to organizing what component goes on what board and what and where and as what part of what process is just like a big task all by itself. And we wrote a CLI app for that, and then we ported that CLI app to Crux, and then we started writing a GUI app using a GUI framework called Cushy. But that didn't end well because Cushy is sort of too experimental, basically, and the community is too small. So we started evaluating egui, which is an immediate mode framework. But the problem with egui is that it doesn't lend itself very well to creating nice, organized projects where your code isn't just one giant switch statement, which is what happens with many egui projects, it seems, or the more mature ones. And it's just, you get main.rs and it's just a garbage bin of just rubbish and just loads of stuff all just bundled together. And that's no way to make a large app that you want to live for a long time and that needs to be worked on by multiple developers. In my mind, anyway, it's not the right way to do it. So what we needed to work out is how to use egui, but try and organize the code base so that you can split it up a little bit better and bring in some of the things that are good from other frameworks, like, say, Iced and Cushy and Visio, perhaps, into egui. So egui is an immediate mode, whereas the other ones are sort of retained mode or hybrid ones. So what we've ended up sort of doing is creating like a hybrid UI, where we've got retained state and we've got immediate mode stuff going on at the same time. Let's dive into it. Here we go. So, GUI, IDE, and this is what we've got. Here's the main window. I'll just quickly show you its current functionality, and we're going to try and improve that a little bit more today. So, we've got the ability to open projects. Thus, we've got a tree, and when we click it, we get extra tabs coming up. And when we click another one, we get another tab coming up. And if we click one of these again, it focuses it, right? The tabs, this tab can be made into a window, right? And you can open another project. Thus, and it's behind it. And you can pull this one out as well, I suppose. And then you can look at two projects. Make this bit bigger. You can look at two projects side by side, which is nice. This one doesn't have any phases yet, so you can't really do much with this one yet. Additionally, and there's a little bit of funky weirdness going on with the dock system. So we'll get rid of this one at the moment. Additionally, yeah, trying to put a dock back in a tab when it's not there is a bit funky at the moment. I'm going to try and work with the GUI doc authors to like improve this situation because it's not ideal. But inside the outer tabs, there's inner tabs as well. You can't mix and match the two. They're independent. So what it means is you can split the window and then split the window again like this. And this is on an inner window. So there's like tabs in tabs here. Too many tabs. I don't know. Well, but what it means is that if you're working on one project and you go, how did I set that up? And then you've got the other project in front of you, you can look at it, navigate to it, and then, copy things into the clipboard or set things up the same way, which is good. Repeatability is key for manufacturing. Repeatability. Anyway, there we go. Right, so let's just move this back into the middle again. There we go. Yeah. So this is what we've got at the moment. We've got columns. Oh my god, we've got a table. Look at this with resizable things, and we can scroll it. It's amazing. We didn't get this far in Cushy. Yeah, and then we've got a tree over here, and we can expand things. And when we were evaluating egui in the last episode, we have this comparison spreadsheet, and we updated this. Sorry for the light mode, dark mode switch. We have this comparison spreadsheet, and in it, I put a yes on the tree view, but that turns out to be a lie. It doesn't have trees. egui doesn't have trees. It has collapsible headers, and you can nest collapsible headers to get the illusion of a tree, but it's not a tree. Like, tree views normally have some kind of way to say, select this node, in a graph of nodes, with multi-selections and, various things that you can do on trees. A collapsible header, of course, is just literally, is it open or closed? Does it have a header? And what's the body in it? And that's it. They're completely different. So in order to go from one to the other, you have to do some futzing around and introduce your own state, an own way of navigating to tree, and an own way of making things selectable and all this kind of stuff. So yeah, yeah, it doesn't have it. Let me quickly show you the code for it. The code in the egui demo. So you run the demo, and we looked at it and we thought, oh look, there's trees. This is the demo, and here's a tree. You say, oh yeah, it's got trees. Tick. No. Not when you go looking at the code. So you look at the code, and inside here there's stuff to do with trees. Yeah. And inside here there's this UI impl, and basically it goes collapsing header. And this is how it works. It basically just keeps calling itself recursively to create more collapsing headers. And then you get a tree. Yeah. So for instance, in my IDE, right, on the left-hand side here, we've got these lines next to the things. And yeah, they've probably done the same kind of thing with this collapsing header too, because this tree view doesn't have lines which goes from sort of like each element to the thing, to the nodes, for instance. It doesn't have lines. It just has a vertical line on the left of it. So this IDE probably also uses a similar approach to creating trees. But previous GUI frameworks that I've used do other things. GUI tree. Are we going to get a picture of a tree? No. Yeah, here's a better one. So for instance, this is like a Windows one, right? Can we make it bigger? No, not really. But it's got lines that go to the nodes. Yeah. I don't know whether there's any more that we can quickly find. Are there any other trees? Trees. Yeah. Ones like this. They've got lines that go to it. And then the line at the bottom changes to be like a different shape if there's nothing below it. Whereas you can't do that with a collapsing header because it doesn't have the information in order to display it properly. So it's cheating. So it doesn't have trees. Anyway. So that's one problem we had to sort out. Okay, so let's have a quick look at the application that we've created now, so that you can see what we've done and what madness we had to go through. Yeah. Okay, so we'll get rid of that. We'll close this, and then we'll open up the project. So, in the MakerPnP project, we've got our Planner app, the old one in Cushy, it's still there at the moment, and this code is currently on a branch, but I'm trying to get it on parity with the Cushy one and then merge it to master. But it's not yet. So, and in there we've got the Cushy one, and then we've got the egui one. And the Cushy one looks like this, where we've got actions, app tabs, context, project, runtime, task, toolbar, widgets, and so on. And then the egui one, for comparison, looks like this. Let's see if I can get rid of this out of the way. There we go. So now we can see sort of like the difference between the two. Yeah. So we've got our main, and we've got app core, which is the same as the planner app core, which is how it talks to the back end, which is Crux. Yeah, maybe I can draw a little diagram. Can we draw a little diagram of the overview of this while we go along? What's the best thing to do this in? We'll try and knock one up in Rita, I suppose. Probably don't create diagrams very much, so I'm not very speedy at doing it. But we need a template. Where's my template gone? Okay, let me open up a workflow one, and then we'll just reuse that. Yeah, this is what we're trying to make, or did make, in fact, and we're trying to make a GUI for this. Let's save this as a new file. GUI overview, something like that, and let's get rid of all the things. There we go. So, yeah. Yeah, let me look at it first, and then I'll come back and try and draw something. But we're ready to draw. So, let's open up main. What does it do? This is the entirety of the main. So, it initializes some logging. It initializes some internationalization code with a couple of languages. So that entire UI that you're looking at is internationalized, which is good. And then it creates a window, and it creates a new UI app. So, what does the new UI app look like? Yeah, we're going to get into it now. So, we initialize some fonts, and we initialize some storage. And the storage is used for like loading and saving things that we need to be loaded and saved, such as the layout of the application, which documents were open when you closed it, and so on. We dived into some of that and the problems with it when we create the tab document example app in egui in the last few streams, but yeah. So then we've got some other stuff underneath here, and this is where it gets all different and weird. So normally with an egui app, you basically have an update method, which is, oh, let me see if I can find it. Normally have the update method, and you just slap all your code in the update method, and then you go to sleep very soundly, and everything's fine. But we don't want to do that. We want to create like nice little components and modules that we can work on independently. And these components and modules need their own state, and we don't want one giant application state because you can't do it anyway because you've got issues with borrow checkers and all this kind of stuff. So somehow you've got to split the state up into the modules, and you've got to architect your applications so that the main depends on the modules that you used, and the modules don't depend on the code that's in main. So So you've got to get your dependencies right as well. So in order to do that, we need to break up our state and have some way for the modules to communicate with each other. And in order to do that, we're using signals and slots. And we're using a crate called Mobius egui, which is a brand new crate. Or should I say egui Mobius? We renamed it. Which gives us some of the sort of like core bits that we need, the signals and slots. But essentially, it's just wrapping channels at the moment. It doesn't do much else other than that yet. But the idea is for egui Mobius to create sort of like a framework of how you can build sort of retained hybrid apps in egui. And we're trying out lots of things in this, and then some of the ideas in this might make it into the framework, and some of the things the framework might go and do its own thing, and who knows where it's going to all end up. But anyway, we're using the signals and slots from it at the moment. Yeah, so we've got signals and slots, which is a Mobius thing, right? Which is this stuff. And then we've also got senders and receivers and executors and runtime. And this stuff is what we borrowed from the Cushy Elm runtime that we added. So with Cushy, it's all reactive, but we wanted to use the concept of messages which are sent when the user interacts with something, which then drives how the application updates in the same way that ICE does, for instance. So we got that. And there's a sort of mix and mishmash of like two different types of senders and receivers and slots and things, which I'll probably end up looking at and see if I can clean up a little bit. I don't know exactly how to do it. This is all very work in progress right now. So I'm not going to dwell on that too much. And then also, if you remember in Cushy, there was something called a dynamic. And a dynamic is essentially, I mean, we could quickly look at it. What's the best way of finding it? Recent projects. Cushy. Yeah. New window. Close everything. In Cushy, we have this dynamic, which basically is an arc that wraps dynamic data, and dynamic data has a mutex in it, right? So it's essentially a wrapped arc mutex, right? So that's what dynamic is in Cushy, but it also has some other stuff to figure out which thread might have locked it, so that when it deadlocks, you can say it's deadlocked by the other thread, for instance. And there's also some other things in there which we're not interested in for this. But I created the concept of a value. Initially in Mobius, it was called like Mobius string and Mobius X and Mobius Y. And I'm like, no, that's no good. We need like the same approach that Cushy had, where you've just got some kind of value or dynamic thing which is cheap to clone, which wraps some state. So we've got this value, and basically this is an arc mutex T. So wherever you see value, just think arc mutex T. So we stick some app state in one of these values, and we keep hold of that. And yeah, that's how we initialize our state. Let's have a quick look at the app state. What's the app state got in it? Why do we need two state things? Well, some state you don't need to serialize, and it doesn't provide, you don't have any way of creating a default for it. Other state is just like, yeah, it's a config file, just save it, load it, easy. So for the bits where you don't know how to create it until you've got all the pieces of the puzzle in order to create the objects, that state goes in app state, and it gets initialized as part of the initialization process. The persistable state goes elsewhere. So the main app, UI app, which is what egui is loading and saving, is this. All right? And this has state, which is a maybe on init value app state. And it's maybe on init because there's default for maybe on init, which is uninitialized, right? But as part of the instantiation of UI app, you can then create the state, and wrap it in a value, and then write it to the uninitialized thing, so that then all future accesses to it are okay. And that's what happens where we were just looking. That's what happens here. So we create that state, but we can't create the state until we've got a sender, and we can't create a sender until we've got a signal, and we can't create a signal until we call create signal slot. This kind of thing. There's no default for any of this. Right. So app state. Yeah. So that's how that's initialized. And because we can't serialize this, and we don't want to serialize it, we have to mark it as not serializable by Surday. And we also need to retain the slot that we create, so we do a maybe on init for that as well. And that happens down here. Right. What does a slot do? Let's have a quick look at the type definition for the slot. The thing that we've got, this slot, is a slot for a UI command. Let's have a quick look at a UI command. A UI command probably looks very similar to probably looks very familiar to you because it's extremely similar to the cushy event that we had. Let's have a quick look at that. So if you remember in main, in the cushy example, we had app message. Right? Let me just see if I can split this up side by side. Okay, no, get rid of that one as well. So we can see the similarities here now. So we've got the egui one, and then we've got the cushy one. Now, I haven't done it yet, and I don't know whether I should. I probably should. But with the cushy one, we sort of wrapped all the different sort of subsections in their own little message thing. So when you're interacting with tabs, you have tab messages. When you're interacting with projects, you have project messages. But the app here doesn't know anything about project messages because the tab knows about the tab kind. And if the tab kind is a project, then you get project messages. And there's this unwrapping of messages, basically, and mapping between them is what we had going on. And we have that in the egui one, but I've only gone one layer deep with these at the moment until I work out how it's supposed to look. So at the moment we've got project command, and then we've got a project UI command. So when you're interacting with projects, project UI commands get created, and then something receives them, and then they get handled into a UI command, and then the update processor for the update for the UI command then delegates back to the project in order to have that handled. But it's only one level deep at the moment. Whereas in Cushy Land, it was about 3 levels deep. So there was app message with a tab message, and a tab message had a tab kind message. And a tab kind message had, maybe one of these types of messages, and a project message. A project tab message had a project message, and the project message was one of the things that you use to interact with it, right? And over here we've got UI command, and it's got project command, and project command has a project UI command, and project UI command has got the things you can do with the project. So it's not quite as deep. Hopefully that's clear as mud. Okay. Moving on. Right. So we were talking about slots. So you create a slot, and that slot is basically a slot for handling commands. And there's 2 parts of this slot system. It works a bit like a channel because it essentially wraps channels, as I understand it. So you have things that can send to the slot, and then the slot needs to handler, which is how the messages get processed. So let's have a quick look at how the messages get processed. So we created our slot back up here. Let's get rid of all these. We created our slot up here. And we created a sender. And then we create a handler for the slot. Right. And it says start and then use the handler down here. And the handler is basically just a function. And it gets called by the slot system when a message is received from a sender. So it then calls handle command with the command that was received. And it clones the UI state and passes and clones the other state. There's lots of state things in this. It's a little bit confusing. So there's the app state and there's a UI state. You'll see. So to handle a command, you need these two state things, basically. So let's have a look at how it handles command. So, handling a command. Takes the app state, takes the UI state. Let's quickly refresh our memory on what app state and UI state was again. So app state is this stuff. So we've got a command sender, we've got projects, we've got a file picker, we've got whether the startup is done or not. Right, and then persistent UI state is tabs and tree at the moment. So the list of tabs and what and how they're arranged on the screen. Right, and then if you get a command, you use your match statement and you go, what command am I processing? Okay, and then you run some code for it. So this is basically like the update method in an iced app, right? And this is where your main sort of like interaction handling stuff should happen. So let's have a quick look at like the first one, showing a home tab. So we get the UI state, lock it and unwrap it. Snark mutex. At some point I might make, like a value get thing, a bit like Cushy had and so on. But anyway, you get back a value guard. And when the value guard is dropped, lock is locked again. And we're calling unwrap on it because we always assume that we can do it. And at some point, we can change this lock unwrap so that it checks to see whether it's deadlocked and shows you a deadlock messages in the same way that Cushy did and gives you a better error message as opposed to just hanging the application. Yeah. So once we've got existent UI state, we can call methods on it, such as show the home tab. The show the home tab finds the home tab through the tree and then sets it to be active or creates it. And we did some of this in our tab document example thing, so I'm not going into that too much. Let's have a look at a more interesting one. Let's have a look at the open file. So the open file one, it uses the app state to do it because the app state has got the file picker instance on it. And you need the file picker instance in order to check to see whether a file is picked. So you go app state, open file, and then it basically configures a picker. Oh no, wait, hold on, sorry. I was thinking, oh yeah. This one is pick file, sorry. Clicked on the wrong one. Wait a second. I'm getting myself confused now. Pick file. Yeah. Yeah. So when you press the open button, it locks the app state and then starts the picking process, right? Pick file. But this is all immediate stuff, so there's no way to know when the file picker has actually finished picking unless you check it. Yeah. right? So that has to happen somewhere. That bit, and this is why I say it's like a hybrid thing, because there's sort of some immediate mode stuff, but there's also some other Elmy stuff, and you have to do some to make the other work. Yeah. Okay, so let's look at the egui update method for a moment. This bit. So the egui update method gets called when a frame is supposed to be rendered. And this is where most of the egui sort of app code lives. And this is all immediate mode stuff. But when you finish picking a file, the egui frame is supposed to be rendered. And at the end of the frame, it basically checks to see whether the picker has been picked. And if it has been picked, then it sends the message to say that it was picked. But it doesn't actually handle what to do with the file that was picked inside the main loop. It just sends a message. So we are still creating messages only when user interactions occur at this point. But the way that we create messages, in some places we have to create messages, is sort of outside the normal places that we like them. But hopefully there aren't too many of these weird edge cases like this. We're going to see how that pans out eventually. So picking a file, go back to where we were. So you pick a file, the file picker runs, the egui frame finishes at some point in the future, and then if the user has picked a file, then another message is created, which is the open file message, with the result of the file picker operation, which is the path to the file that was picked. Okay, so then open file gets handled. And then that delegates to the app state, and that says open file. Right. And this is where a project gets created. So here we're creating a label for the project, and then we're creating a signal and slot for the project. That is so that the project can handle its own messages, and so that other things can send messages to the project. But in order to be able to distinguish between the different projects that you've got open, because you can have multiple projects open, you need the key for the project. Now, in the tab document UI example, you might remember we had an image document, we had a document, and the document could be of type image document or a text document. And the document tab knew that it had a document, but the documents are held by the main application state, not by the tab. And that's the same here, whereas the projects are owned by the application and not by the tabs. And there needs to be some way to sort of get the right document from the application and then work out what kind of document it was and then delegate to the right thing. And in order to do that, you need keys for tabs and keys for documents so that you can find out which one it is and who sent it. If we go back to our UI command for a moment, you remember that the project command has a project key in it. Whereas in the tab document example, we had a tab message, right? And that had a tab kind message, and the tab kind knew about its tab identifier, and the tab kind also knew whether it was a document, and the document kind knew about the document key and also about the type of image, the type of thing that it was, rather than the main app knowing about the document key. So that's a little bit different here. So this is why I'm saying that I think there might be one level of nesting that we need to put back in, which is the tab messages, so that we can hide this project key in the thing that owns the project, which might be a tab or it might be something else. Complicated. Anyway, right. So open the file. We need keys to distinguish which project the message is for. That's the basic problem that you got to solve if you have more than one. So you have to create a project mapping. The project mapping goes from the command sender, and this is the command sender for the UI command. So if you've got a UI command, which is a project command, it needs to send that contained value to the right project instance. Let's see if we can draw some of this maybe now. Let's have a look. So we've got, I suppose, an egui app, and then we've got some projects, and then yeah, let's have. It's a bit complicated to draw all this. Then what? Yeah, and I guess we've got a sort of command, and it's got two parts, and it's got the key, and it's got the message, and this thing knows about its key, and this thing knows about its key. And then the flow is sort of like egui creates a command thing, and then there's like it either goes here or it goes here depending on the value of the key. Yeah, it's not very easy to explain like this. Yeah, let's get rid of that diagram. It's bad. Yeah. Yeah, not quite like that. I'll try and draw some better diagrams for this because I think it would probably help explain it and then stick them in the repository. But diagrams, good diagrams, take a bit of time to create. Yeah, there's a lot of moving parts to this. Even just trying to remember them while we're going through all this now, it's just like, oh, you need the code in front of you. But yeah, so somehow you need some way of going from a UI command with a key to a project command for the project. And that's what this bit's all about. And then eventually you create a project from a path and you give it the sender and the slot. And the slot has the handler on it, if you remember. And the project slot handler, yes, is created by the create project mapping. And this is the handler for the project. So it basically goes, okay, I'll take that project command that I received, and then I'll send a UI command, but I'll wrap the key for this project and the command that you want in a UI command. So this is where it does the wrapping. Right. Yeah. 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 Okay. Right. So, yeah. So creating a project creates the key, and you only get the key after you've inserted it in your list of projects. And then you can create a tab for the project of a type project tab, because there's home tabs and there's project tabs. And in order to create a project tab, you need a project key so that the project tab knows which project it's for. And then you can use the UI state to add a tab of the type that you just created. And when you create a project, it gives us two things back. It gives us the project that we just created so that we can put that in a tab. And it also gives us a command to send once we've done that. So in the from path, there's a project UI command load. So when it creates a project, it creates the instance, puts it in the tab, and then a message gets sent, which is project UI command load. Right? and it uses the command sender to send a project command with the project key with the command that was returned by the from path, which is the load. So eventually what will happen is the project slot will receive that command. Wait. Wait a second. No, this is going the other way. Oh, there's too many things. Hold on. Eventually that command will be received by the project. Let me find where that happens, because I've lost it myself now. Yeah. That's right. So that project command was wrapped in a UI command, and then the UI command handler goes, oh, I've received a new command. I'll delegate it to the project. And this is how it delegates it to the project. It receives the command with a nested UI command, grabs a bunch of state, finds the project for which the command is intended to go to, the destination, and then it calls update on that particular project instance with the command that was sent. And then the load can be handled. Oh my god. Then how does it load? We're going down the rabbit hole today. So how does it load anything? It uses Crux, right? Remember? Because we had our CLI command, which could load a project and then you could interact with it. And we had our Cushy app, which could load a project and interact with it. And now we've got our egui app, which can load a project and interact with it. And the interactions to the project are all done through Crux. So Crux holds the project state. The GUI app does not hold the project state. Can we draw something? I've totally forgotten how to use this tool. That one. And then we want to, was it this one? And then where was the brush size? Who remembers where the brush size was? No, not me. So essentially there's a Crux over here. And then we've got egui over here. Right? Well, okay. Let's get rid of that. We've got the planner app over here. Planner. It does say planner, trust me. Crux planner. Core. And then we've got planner UI over here. Right? And this holds one project. An instance of a Crux planner core holds one project. Oops. That's not a spell project. Project, right? The UI can be used to work with multiple projects. So you've sort of got egui like this, egui. And then you've got tabs. And then you've got projects. And these are plural. And then inside a project, you've got core. And this is where the interaction happens. Right. And inside the project, you've also got the stuff that comes back from the core, such as the views. plural again. What views am I talking about? Well, in order to display the project tree, you say crux core, give me the project tree, and it gives you an object back, which is a pet graph of nodes which represent how the project is structured. And this we retain in the view, right? So that when a GUI is trying to render itself, we've already got the information and we don't get it from the Crux app every single frame, right? We just keep the bits of state and information that we're interested in. In addition to that, we also have to remember our own sort of like UI state, right? So for instance, the tree view, let me see if I can just bring this up real quick. This tree view over here on the left, right? That's the tree that we're just talking about. When I click on one and then look at it again, it knows every frame which one of these is selected. And therefore, there must be a little piece of state somewhere which says which one of these is selected. Because the Crux app doesn't know what the GUI app is doing with the tree. So the Crux app doesn't retain the state of selection or anything like that. It just says, here's a project tree, and that's it, right? So in addition to holding on to the data for the views that the Crux app gives us back, we also hold view state, view states, I suppose, like this. And again, this is plural. And one of these might belong to one of these, right? So you have a state for a view. So for instance, you go, give me the tree view, and it gives you the tree view back. And you go, okay, great, I'm holding on to that. And then at the same time you do that, you create the state that says which one is selected, you know, option none, or hash map of node, or something like this, with a flag that says selected. So that when you're rendering the tree, you can refer to the view to work out what the label of the node should be, and then also look at the state to work out whether that node should be selected or not. Okay. Yeah, something like that. Yeah, okay. Back to the loading. So the project GUI is using a core to send commands to the core to make it do stuff. Right, so it says plan a core service update, and this is the event that we want it to do, and we'd say we want to load this path. Right, these events are from the Crux core, right, and they're defined in the Planner app, not in the Planner GUI, right? Probably been a while since we looked at these. And then what happens? Once the update has finished, we call map on it. I spent about half a day trying to work out what the best way of doing this is, but this is what we ended up with. So if you remember in the Cushy app, we were using chain, right? But it turns out chain isn't the right thing to do, because it doesn't care about whether that command succeeded or not. So if the load failed, for instance, what do you do? How do you know? What are you supposed to do? So let's have a look at what update gives us back. So the method signature of this update is a task which contains a result, which contains a project key and a UI command, or a project error in the case of failure. Right. The update method basically goes, okay, process the event core, and the core can say, well, I need you to do this, and I need you to do that, and I need you to do something else. And therefore, you've got a list of things that you need to do. But you're only getting one thing back. So we need something that a single thing that can be returned that can hold multiple things to do, which is why we've got tasks. Because task, which we shamelessly borrowed from Iced, implements an option box stream. So a task can be one thing, like done, or it can be a batch of multiple things. And you can also go from one thing to another thing. So you can chain things and map things and all this kind of stuff, right? And if you're a particular type of task where you return a result, then you can do other things such as and then and map error, which turned out to be not useful in this case, but I wrote them anyway. Well, I didn't write this one, but I wrote this one. Because, like I say, some of these were shamelessly borrowed from Iced. But, you know, if it works for the entire Iced community. It can't be that bad, right? So, yeah. So we've got tasks. So update returns a task of result. And this task can be more than one task, because we get a batch task at the end of it, right? So, in order to create this list of tasks that needs to get done, it processes the effects that the core says should happen. There are currently only two effects that can happen. One is render, and the other is render a project view. The view renderer just returns the view. The normal render just returns a very simple object at the moment, which contains either an error message and a modified flag. If I remember rightly. Modified and error. That's all you get back. So you say do something core, and it says modified or error. That's it. That's all you get. So, in the case of an error, we need to do error handling. So in the case of an error, we need to take the error from the view that came back so that we don't process it twice. Then we create a new task, which is done. It immediately emits this result. And we immediately say it's an error, project error, core error with the error that was returned, which is just a string. Okay, so then what happens to this error? Let's look at the unhappy case first, because it turns out the unhappy case was more involved than the happy case, which is often the way. So we've got an error. So then from here, we've got a task, and this gets returned, and it gets added to the vector of tasks. And then this vector of tasks, one of which is a task with a result of error, gets put in this task batch. Right, and that gets returned by the update method. Right, so then we take that result of that task. But wait. Yeah, we take that result and, oh, wait, on the wrong way. Yeah, and we call map on it. And this is on the task API. And it then basically takes the function that you supplied and calls then and creates a task which immediately creates the output with the result of the function that you call. So So you either get here a project key or command and project error. And then you've got to map that result as well. So you've got to map the task, and then you've got to map the result that the task had. It's a bit confusing. And if it was good, then this function, this is what gets returned by the task, and that's what the task eventually emits. Right? But what happens to the bad one? Where'd the error go? What happened to the error? Yeah. So we map the task, and it goes task done with the output of the function. So if we map the result, map on a result, it calls the function if it's okay, otherwise it returns the error. So this must be returning the error in the case of the error. So therefore this map must also be returning the error in the case of an error. And then this whole thing here is supposed to return a task, at which point we've got a task with a result with an error in it. Aha! That's where the error went. It gets returned by this. Then what happens to it? Oh my god. So that task gets mapped again. And you get the result. And that could either be a project key or a command or an error. Or a project command with... Start again. It could either be okay with a project key and a command, or it could be an error with an error. And if it's an error, we create a new command and we put the error in a project UI command error. And that then gets handled by the normal process of handling everything, which it turns out is this same block of code. So now, eventually, this error, this command, will be given to this update method again, which will then come along and go, how do I handle errors? And it goes, oh, this is how I handle errors. And it goes, okay, if the error is of a type project error, if the error of type project error is a core error, then take the message out of it and hold on to that message. Then what? But you're forgetting something, aren't you? We've updated the state. Now what we've got is our state contains a list of errors. Let's go back to our little diagram. Projects, I suppose. Let's draw another little box here. Errors. That's what happened to it. It got put in the project. Right? Self errors. Vector of strings. List of errors to show. And it lives in the project state. Okay. So we're updating state. Great. And now we've got presentation. Right? Let's dive into the presentation. How does the presentation of state work? Okay. Back to main. So main goes no, I'm looking at the wrong one. Too many mains. Okay, main goes create a new UI app. And this is just like regular egui stuff, right? And it goes new. When you create an egui apps, you implement an egui trait for your app. You implement this for your app. One of the things that you're supposed to implement is the update method, right? And you basically get a mutable self, which is where it normally goes pear-shaped in egui apps because everything's trying to mutate state while you're trying to do the presentation. But we're not trying to mutate state anywhere in here. That's handled in all the updates and slots and tasks and all that kind of thing. This now is just the presentation side of things. There are the odd egui bits, though, which do need mutable state and so on. For instance, the widgets. Some of the widgets need to be able to mutate themselves. So, yeah. Yeah, we'll come to it. Okay, so rendering. So we've got all our state, we've got all our lovely state, we've got our tabs, we've got our projects, we've got our errors, we've got our core, we've got our views, we've got our view states, and now we need to render it all. How does it work? Well, we create a top panel, we stick a menu bar in it, and we create a toolbar with some buttons on it. And the top bar is this area up here, menu bar is this thing over here, toolbar is this bit over here, right? Great. And yeah, then we have some immediate mode malarkey. I haven't yet found a better way to do this on startup stuff because, you know, to me, this is a waste of CPU cycles, and I wish there was just a single event that was called by a egui app, which gives you a context that you can futz around with. But anyway, there isn't. So we have to do a little bit of futzing around with the state to check to see whether startup is done, because if startup is not done, then you can only display the home tab if you've got a window, and you don't get a window until update gets called. So, you know, showing tabs, kind of presentation-y stuff, right? I mean, it is. Let's have a quick look. So show home tab on startup basically goes show home tab, and you know, it adds tab to the list of tabs, and then yeah, and that's creating the state for the UI. So not totally hideous to have it there. And same again with restore documents on startup as well. Maybe there's a better way of doing this, like emitting messages or something. But we need to do some futzing around with the doc state and the tabs and telling Crux to load the documents again. So that's what this on startup stuff is doing. So then what happens? We create a tab context. A tab context contains a sender, the config, and the list of projects. And we borrow those from the app state, which then gets dropped here. I guess actually we could call this only once here, I suppose. Yeah. No, actually that app state gets dropped here, doesn't it? And this app state gets dropped here. But we're cloning the things out of it, and the tab context gets dropped back down here. Right. We need to clean up tabs, and this is a workaround for some bugs in egui doc. I went over these in the previous streams. Anyway. Then we grab the UI state. So we've got our app state, which we copied some things out of that were wrapped in values. And then we've got our UI state. And we need to get the tabs out of it. And the tabs is living in a value so that the list of tabs can be mutated. Yeah. Yeah. And then we create a doc area with a tab viewer. And then the tab viewer implements the the traits required to do it. We'll dive into that in a moment. Let's have a look at the tab viewer. So the app tab viewer has the tabs and it has the context. The tab viewer implements tab viewer, and it deals with setting tab titles and rendering the UI for each of the different tabs, right? So if you've got a project tab open, UI eventually gets called by the doc state code, by this doc area code. This show method will delegate to the tab viewer, and the tab viewer will call the UI method on each tab, right? So you end up in this UI method. And then depending on what type of tab you are, and you're a tab key, then you can get your tab from the list of tabs. And then you get a guard on that, which is dropped at the end of this method. And if you get your tab from the list of tabs, then you get a tab instance. And then you can delegate the UI method to that tab instance. And we've got a few different types of tabs that we can display. The main tabs that we display are the home tab and the project tab. But the project tab also has tabs, and inside that it has a project explorer tab and a phase tab currently. But it's not even quite as simple as that. So we get our tab instance, and that's of a type tab kind. And tab kind, oh my god, tab kind implements tab, and that's how it delegates it to the right type of tab. So this is what will get called by the docking codes UI method. Then this delegates it to the tab implementation for the tab kind, and the tab kinds are what the docking system has. Yeah. And then this goes match self, and this tab kind is an enum. And if it's a home tab, then it delegates it to the home tab's UI method, which then can render the home tab, which uses Taffy to lay out some stuff, right? So if it's the project tab, then it delegates it to the project tab's UI method. So the project tab basically needs to find a project from somewhere, and it gets the list of projects from the tab context, which I suppose I can rename to tab context like this now. Here we go. So you get the projects, and the projects here is a value arc mutex of a slot map which is indexed by a project key, and each entry in the slot map is a project. So then you say, okay, we'll get the project for the key for my tab out of the list of projects, and then call project UI, which has now got nothing to do with tabs anymore. So this block of UI code doesn't know that it lives inside a tab. Doesn't know anything about tabs. Except that it does know about tabs because it has its own tabs. But that's the only thing it knows about tabs. It doesn't know that it itself is in a container, which is a tab container. Because I literally just opened this and I saw clean up tabs after saying that it doesn't know anything about tabs. But it does, because it has its own tabs, right? What tabs does it have? It has these ones, right? It has this one, and it has this one, and it has this one. It's got its own tabs, right? So you've got parent tabs, then you've got a project, and then the project has project tabs. Oh my god, it's complicated now. Right, so project, we were still trying to work out where those errors went, right? So now we've rendered, what have we rendered at this point? If you're managing to follow along, just like comment, say, yes, everything totally makes sense. I totally understand it. See how many comments we get. So what we've managed to render so far is the menu bar, the bit at the top, the toolbar, the tab area, and now the project is now rendering itself. So we've got this bit at the top here, right? That's what this bit is. We've got a panel, which is this area at the top. And then underneath that area at the top, we've got another dock area, which is this area here. Right, if I closed all the tabs in here, this is what you get. You've got this blank area here. This is the dock area. Right. And then look. The project errors. We've got some code that handles project errors. It goes, if the list of projects isn't empty, then show the errors modal. Okay, so how do I make this happen now? If I open a project that is not a project, surely that should give us an error. Let's open a CSV file. Yeah, there we go. Huh. It took a little while. I don't know why it took so long. Anyway, so what we've got is an error message in a dialog, and that's what happened to the error. So every frame, and you can see that it's still rendering this every frame because there's a little spinner over here and over here, which are still spinning. And they wouldn't be spinning if this wasn't being rendered every single frame. So we took the message from the Crux core once and we stored it in the state of the project, which was this, if you remember. That's where the error went. It's now living there. And we haven't taken it out of there, and it's still there, and it's still there every single frame that this UI is being rendered. However, if we click OK, something happened. What happened is the list of errors got emptied. But how and where did that happen? Let's have a look. So showing the errors modal creates a new modal, and it adds the heading, and then it creates a table with the list of errors in it for every error, because there could be more than one error. Right? And then it has an OK button on the right-hand side, which is this bit. Add right. Okay. And then it adds a button. And when that button is pressed, the project emits a project UI command of clear errors to the project sender, which eventually gets processed by the project's update method, which we saw earlier, when we were looking at how it loads it. So that's how the errors get cleared. Let's have a look at how the errors are cleared. This is where the state is mutated for the errors. So it literally goes self errors clear. And then the next time egui renders itself, this bit will evaluate false, and therefore it won't show the errors modal. And that's what happened to the error. We made it. Error handling. Yeah. Now what? Okay, let's deal with a happy case. So we were looking at loading, right? Okay. So we got our tasks, And then eventually we got a task which had a result. And if that result was not an error, then we issue this. We say loaded. So the message gets received by the UI app, and then it gets delegated as a project, the particular project instance's update method, as in this method. And then eventually the match statement ends up down here. And then it dutifully locks the state, sets a flag, and then uses the core service to request a view and also chain that task with another task which says request another view. And he doesn't care about their errors on this one. He doesn't do any specific thing with it. So the reason why there's mapping here and chaining here isn't immediately obvious. The reason we have to do the mapping in the first case when we're trying to load something is if we immediately tried to chain to this command, we would say that it was loaded even when it wasn't loaded. And therefore we would end up trying to request views for a project, but we weren't able to load the project, so the core won't know how to do that, and therefore it will give you another error message back. So we don't want to create additional messages for the core unless we load it. So that's why we need to handle it slightly differently there. So we're requesting views. Right. Requesting views. So the views that we requested were the overview view, and then it gets even more complicated here because the first view gets requested directly. The second view gets requested as a result of a view request for a particular type of view, which is a bit weird, but because here we're interacting with the core itself directly, whereas here we're sort of telling the UI to do something else which requires a core interaction. So this request view is handled by this, and it says if this view request is project tree, then the event that you're supposed to emit is the request project tree view. So here we've got an event, and here we've got an event, right? And then this interacts with the core again, and also returns any tasks that are required, right? So in the case of a request overview view, instead of the core telling us to render something, it says instead of that, and if you remember the render was just the modified or an error, it says please render this view. The Crux core tells the client, the egui app, as in this is telling this to render something. It says update the view with a view. And the view that it returned is a project view. And the project view that it is returning is either going to be, one of these ones, right? And these are defined in the Crux app. So the overview view contains like the project name. The project tree view contains a pet graph of project tree items, which contain key args and paths, right? So it says, here's a message, here's the data, here's the view, here's all the data for the view that you need. And that's how the view data gets into here. Well, not quite. That's how it gets passed back to here, sorry. But the way it ends up over here in the views is because we've got an update view handler in, oh my god, in, so here we're requesting views and now we're updating views. So we get that message back and it was an update view message. All right, that update view message is this, so it gets processed. You get the view, and then if it's an overview view, then we get the project's UI state, and we extract bits of the view out of it that we want in order to put it into the state. And in the state, we've got a name field, which is an optional string. So when you first say load, you don't know what the name of the project is because the name is contained inside the project file that you're just loading up. We don't know it. But once we've got to here, we do know it. Let's have a quick look at the next view that we requested. The other view that we requested was the project tree. We saw that here. So that project tree gets returned back to us here, the one that we requested. So again, we get the project state and we tell the project tree to update itself with this project tree view. Might rename this one. Project tree, update tree, project tree. Yeah, this one should probably be called project tree view, I think. Yeah, like here it's called project tree view, an overview view maybe. I might rename these. Anyway, it says update tree. And all it does is just retain that data in itself. So one of these views is a tree. And the other views, which I haven't got to yet, will be like phase placements. Phase placements. And there's multiple ones of these, and there's only one of these. Tree. PPS underscore. So we've got a project tree, and we've stored the entire pet graph that was given to us. Great. So what that means is when we're back in rendering land, which was this in the project, right? We're going, okay, we're rendering tabs. And we're back into tabs again. So the project has got its tabs. And if one of those tabs, oh my gosh, is a Project Explorer tab kind, which has a Project Explorer tab, then eventually, using the same approach to delegating to tabs that the main app itself had, eventually this UI block here gets called, which can then, and this is living in its own file all away from all the other egui code. And if someone wants to work on the project tree, then they can futz around with it and they won't be stepping on anybody else's toes, and they won't be, poking around inside the project's update method and adding mutating state and doing all their weird things that they might want to do. No, they are constrained. They are constrained to doing GUI rendering here and here only, which is a good thing. So they say, okay, well, if we've got a project tree, then show the project tree. If we don't have a project tree, show a spinner. Which is why, currently, No, we didn't open a tab. I tell a lie. We've got some spinners there. But we didn't quite get to that bit. Hold on a second. Let me go back to the project rendering bit. Wait. Wait a second. Hold on a second. What's going on? Yeah, no. Sorry, I was right. I'm thinking I wasn't. I was right. Which is why we've got a little spinner over here. Because when we fail to load a CSV file as a project, we open the Project Explorer tab, but it doesn't have any information to display. So that's why in the Project Explorer tab, it is running this bit of code here because there's no project tree. But if there was a project tree, it would render it using this method, which basically takes all of the nodes, creates collapsing headers, and then calls itself recursively. Show project tree. And it pulls out the key, the arguments, and so on, and renders a header for the tree node, I suppose. It's probably the best way of saying it. But if you remember, we had that state, that other bit of state before. So the labels and so on, it's pulling out of the view that was returned by the Crux app. But the state for that tree node is coming from somewhere else. That's where it's coming from. And this is where it's used. So to show the project tree, you need a Boolean. You need a Boolean. And that Boolean needs to be mutable because of egui. So it's sort of like, this is where it's sort of like not true reactive, not true immediate mode. It's somewhere between the two. But the immediate mode part of it needs a mutable thing so that egui can adjust the value contained within that Boolean and then return it or let it be used by the clicked method, I suppose. And then if this Boolean is then, changed or whatever, then you can emit a message. So this is where we're emitting a message if the Boolean is changed. So what we're doing here is saying if that header is clicked, then emit a command called project GUI command navigate with the path from this particular node's path. And if you remember, the nodes that we're looking at are the project tree items, which contain a key, argument, and path. And this path is how the UI can open up other tabs and things depending on what you click on in the tree. That's its purpose. And that's how the tree is rendered, and that's how the state for the tree is used. Let's have a quick look at the state for the tree for a second. So this show project tree, when it's called, gets this selection state. I'll call the press the wrong one. This one. It gets that selection state, and let's have a quick look at this. So the project tree contains the tree view that was returned by the Crux app, and it also has this tree state, which is a hash map of a node index and a Boolean. And that's where the I'm selected, I'm not selected information comes from. Let's have a look and see what happens when that navigate message is received. So project UI command navigate. So we go back to the project and we'll search for that. So if a user clicks on one of the nodes in the tree, you'll get this message eventually. And it tells the project tree to select that path. So then the project tree then has to iterate through the graph and find the node that's got that path, and then find the corresponding Boolean state, the Boolean flag for that node, which is in the hash map, and set it to true. That's how it does it. Select path. So it goes find the node and then clear all the state and insert a new node with the flag set to true. That's how it does it. So that hash map actually only ever contains like one entry. But at some point, I don't know, maybe using a hash map was the wrong thing there. Maybe we just needed to store the node index. But I just have this feeling that I'm going to need to do multiple operations on multiple tree nodes, and multiple tree nodes might need to be selected at the same time. You know, just like you can over here. So anyway, and again, this illustrates the difference between the collapsing headers approach to rendering a tree versus an actual tree. Because here you can see the selection, it isn't just on around the file name, it's across the entire horizontal width of the tree, which is how you want it, really, for multiple selection. Anyway, I digress. So yeah, we update the project tree state, and then we have to deal with the navigate itself. So to deal with the navigate itself, we basically have to do some futzing around with regular expressions. And if the path started with project and then phases and then a phase reference, then we extract the phase reference from the path. And then we say show phase using the phase reference. And the show phase will create a tab if the phase hasn't been displayed yet, as in we don't have any state for that phase. If we do have some state for that phase, then we find the tab for that phase and then focus it using this. So phase states, yeah. So, but we've got a tab and we're saying show a phase, but there's no information for the phase yet. So we need to tell the Crux app to retrieve information for that phase. We need 2 bits of information this time. We need a phase overview and we need phase placements. Yeah. Yeah. So we create 2 tasks. There's no error handling and failure to be done with this. If it fails, it fails. You just basically won't get a view. You'll get an error instead, and then the errors will be handled like they were before. But if the task results in the effect of a view renderer, then the message will be emitted, which is the render view message, which then gets handled by the update view message handler, which will then do these 2. So the phase overview. So if you received a phase overview, then you can get the phase from it, then find the phase in the project's phases state, which is a hash map of a phase reference and a phase UI. A phase UI contains the phase overview and the phase placements. And If you've got it, you get it. If you haven't, you make it. That's what's going on here. And then it says update the overview. And again, this is just keeping the information that the Crux app gave it and storing it. So that was this little bit down. I can't quite see it. Let me make, oh, that's too big. Over here, this bit, the phase state thing. Let me drag this over a little bit. Yeah, in the phase state, project phase state, that bit. Oh my god, too big. There we go. That's the right size now. So it saves it in its state, and it does the same thing with the placements as well. Both of these work very similarly. They just retain the state. So then what happens? Oh yeah, we've got the crane, we've got the phase state, we've got the phase, the phases. Yeah. So now we've created phases as a result of receiving a view for a phase, but did we create the tab for it? When did we create the tab for it? We haven't created a tab for it yet, right? So something somewhere needs to create a tab for it. Because here we said navigate, and we created some tasks to get the views, and we batched them up and received them. But we haven't got any tabs added yet. So where's the phase tab get added? Let's find out. Yeah. Phase tabs, project tabs, projects, projecty. Add tab must be called by something, right? Phases. The show phase gets called. Oh no, we did do it. We did do it. Show phase was called by, yeah, sorry, that's where it happened. Yeah, that's where the tab was added. So the tab was added there. So the tab was added, then we request the data for the tab. Yeah. So if we close this one and open this one, we can see all the stuff that we've been talking about in action when I open this file. So we created a project tab, we displayed the header, we asked for the project view request, the spinner where the name was got changed into the name on the receipt of the project overview. We requested the project explorer, the project explorer view was received. Then we display the Project Explorer in the Project Explorer tab. And then we can click on these things. And when we click on it, we created a phase tab. We created a phase state, somewhere to hold the information about the state. We emitted the two messages to get the information for the phase, which is the overview, which is used to display this, and the list of placements, which is used to display the table underneath it. Yeah. That's how it all works at the moment. Oh my God. And yeah, that's where we're at. Oh my God. That's an hour and 41 minutes of explanation, that is. That's a lot of stuff that's going on. No wonder it's hard to remember. It's nuts, isn't it? It's nuts. Creating productivity style user interface applications with the Crux backend and retained state and egui immediate mode UI is a non-trivial task, it turns out. Who knew? I certainly didn't think it was going to be that complicated. But apparently it is. And then we've got closing tabs. Okay, so that's the state of the app as it is at the moment. There's some quirks, but there's nothing that, you know, I either don't know workarounds to, or don't bother me too much in the scheme of things. At the end of the day, we've got a GUI app written in Rust that's using a fairly sort of like sane approach to structuring the application, which as the application grows, is probably going to be workable to allow multiple developers to work on it together without treading on each other's feet. And I think that's a what's the word I'm looking for? Mendable? Yeah. Sustainable, that's the one. A sustainable approach to getting things done. That's the one. Yeah. Oh, yeah. That's where we are. So, if this was interesting, press the like button below, or comment, or join the Discord server, or just otherwise say hi. You know, be nice to hear from people that are watching the stream. So, yeah. So what are we going to do on the next one? What are we going to do on the next one? Well, I'm not sure what we're going to do on the next one, but later this afternoon, because my voice is dying now after this nearly 2-hour explanation, what I'm going to have a go at doing is to add a toolbar to the project. So if you remember, let's run the cushy one. This one. And both of these are still in the repo at the moment, and they both still use the exact same backend, which didn't need to be changed for the egui app. And that's an important point as well. So we've now got two applications which basically can open the same file, right, and show the same kind of information. Let's stick them side by side for a moment. That'll be fun. Here we go. Let's pull this over here. And let's just display this over here. Right. So in the cushy one, there's no inner tabs. There's no rearranging things. We could switch between tabs at the top here, but there was no way to look at two of them at the same time. So the egui one is immediately better in that regard. So I can open two files and look at two different files, and I can even put them below each other, right? So that's nice. We did end up showing a list of placements, but in in Cushy, there was no table widget with, like, you know, resizable columns and things like that. So we'd need to actually implement all this kind of stuff in order to render this properly. Additionally, there's some weird rendering errors on here. I don't know whether you guys can see that, but there's like little vertical lines everywhere. That's weird. Yeah, rendering errors. That's not ideal. Hadn't noticed them before. We can switch phases. The cushy one doesn't resize as you rearrange things. Look, there's this black border, and then it goes. I am in debug mode here. And the egui one, also in debug mode. You know, it's rendering every frame. It's not having problems with the slowness of it, which is good, because I wanted to see that. So that's good. Yes, so those are what they look like side by side. So the thing that I'm going to do next is to add this toolbar at the top here. And if you remember from previous ones, we needed forms with like form validation and all this kind of stuff. So I'm going to have a crack at adding this toolbar and implementing these forms in egui and making that work. That's what I'm going to do next. So we'll see how far we got on the next stream. Yeah. Right. So there we are, people. Hope you enjoyed that. It's quite interesting going over it all. There's so much. It's nuts. So just remember, folks, it's only software. How hard can it be? We'll find out on the next one. See ya.